Today, we're going to create a production-ready rock shader in Unreal and Unity. Let's go! So before we get too far into creating our own rock shader, I want to show you this one. It's an example of a rock shader that ships with Unreal. This shader is nice and simple, and it works fine for a rock asset that's all by itself. You can see it has a diffuse texture, a hard-coded roughness value, an ambient occlusion mask, a normal, and it also has a detail normal, which is nice. And this is what the rock asset looks like with the rock shader applied to it. This asset is fine, but there are some production considerations that we need to take into account. Generally, when artists use rocks in an environment, they like to scale them up like this and then just kind of jam them together. So if I take this rock and just kind of jam it in with that one, now what you can see is the textures are pretty blown out on this rock that I scaled up. And where it comes together with the other rock, you can see that because the texels are much larger on this one than on this one, they just don't match up very well. And so this is one of the problems that we're going to try to solve today when we create our rock shader. So we're going to create a shader that gives artists the freedom to scale rocks however they want, and the texture sizes and texel density will stay consistent. So first, let's switch over to Photoshop and take a look at the textures. All right, so this top row of textures represents the textures that are being used by the shader that ships with Unreal. So we have a nice tiling diffuse texture, and then we have a normal map here that goes with the mesh that we created, and we also have our ambient occlusion map, and then we have a smaller detail normal map. So this is kind of using the technique that I showed last week with the snow, where we have a normal map that has our regular detail in it that goes with the mesh, and we have another normal map that has the really tight detail. So this is a great technique for making sure that you can have detail up close. And if we switch back to Unreal, you can see that if we zoom in close to this rock, there is a nice detail normal. However, the shader that we're using here is only tiling this detail normal twice. You can see our texture coordinator is getting multiplied by 2. And so if I zoom in too close, it still kind of falls apart. So we don't have a detail normal here that's doing a lot. It's just kind of multiplying this detail normal 2 times and adding it in. So what we're going to do for the shaders, for the textures in the shader that we make is, first of all, I did make one adjustment to our diffuse texture here. You can see that the diffuse texture by default is pretty dark. So I did a levels adjustment here just to make this diffuse texture a little bit more PBR compliant, so it's not getting quite as dark. The next thing that I did is in the alpha channel of our color texture, I'm storing the roughness. And so I saved this texture as rock underscore CR, and the CR stands for color and roughness. Now, the shader that ships with Unreal doesn't have roughness, it just has a hard-coded 0.6 roughness value. But I'm using a roughness texture to get just a little bit more variety out of the specularity or the roughness. All right, the next thing that I've done is I've taken the normal map here, and in the blue channel of the normal map, I've packed the ambient occlusion. So the shader that shipped with Unreal was using one normal map like this, and the ambient occlusion was stored in a separate texture. However, by putting that ambient occlusion in the blue channel of my normal map, I'm able to save a texture sample. So you can see I'm sampling 4 textures here, but I'm able to do a little bit more with those textures because I'm packing my ambient occlusion together with my normal map. Now for detail normals for my shader, I have 2 different levels of detail. This one is the micro detail that we're going to be using. And this is what we'll use when you zoom really close to the rock. And then this is the texture that I'm using for macro detail. And the reason that we have macro detail is to enable us to scale the rock really large and still have tight detail. We noticed when we looked at the scaled up rock that was using the Unreal shader that detail fell apart pretty quickly. But because we're going to have both a micro detail texture and a macro detail texture, we'll be able to scale the rock up and still zoom in and get really close to it and still have nice crunchy detail when we're far away, even if the rock is scaled large. So now that we have our 4 textures here, let's go ahead into Unreal and create the shader there. And then we'll switch over to Unity and create it in Unity as well. All right, so let's take a look at our textures really quick. You can see that here is my diffuse texture, and my diffuse texture is set to DXT1. It's has sRGB on because it's a color, and you can see that the actual format is DXT5 because I do have the roughness packed into the alpha channel. Here's my normal map. And this one, you can see that I am not saving it as a normal. So normally a normal map would be set to normal map compression, but this one's set to BC7. And the reason that I've not set it to normal map is because I've got that extra data in the blue channel. If I do save it as a normal map, that data will go away. I won't be able to store it there. And so that means I have to save it as BC7. And then there are a couple of things that I need to do manually in the shader to do the unpacking. And I'll show you that in a minute when we start building the shader. All right, and then here's my detail texture, my micro detail, and here is my macro detail texture. And these are the 2 textures we're going to use to add extra detail when you zoom in close to the rock and also when the rock gets scaled up. All right, well, let's go ahead and create a new shader, and I'll show you how to do it. So I'm going to create a new material, and I'm just going to call this Rock Production. Let's open that up and get started. Okay, so the first thing that I need to do is bring in my textures. And so I'm going to go to my textures folder here, and I'm just going to do a search for rock. So I need my rock detail. I need my rock macro detail. I need my rock NA. And this is called rock NA because it has normal and ambient occlusion in it. And then I also need my rock CR, and CR stands for color and roughness. And those are my 4 textures. All right, before I use these textures, I'm actually going to show you the technique that I use for scaling the UV coordinates. So let's bring in a set of UV coordinates. And now what we need to do is scale these UV coordinates by the size of the object. So here's a node called Object Scale. And if I grab this and I multiply my object scale by my UV coordinates, let's see what happens here. So what I'm going to do is, just so that we can see what's going on, I'm going to add a frac node here just temporarily. And I'll wire this into my base color. Now you can see that it's giving me an error because I'm trying to multiply a vector 2, or my texture coordinates, by a scale XY. And so what I need to do here is just add a component mask. And I'm just going to use the X and the Y instead of the X, Y, and Z. All right, so now you can see I've got my nice color for my UV coordinates. And I'll save that, and I'm just going to go ahead and apply this to my rock in my scene. Okay, so here's a couple of rocks that I've applied my rock production shader to. Now what I want to show you is, right now my UV coordinates are just applied 0 to 1, but because I've multiplied by the object scale, if I scale my rock up, now you can see that the UV coordinates are tiling over and over again, and they're basically staying the same size, even though my rock is scaling up. And this is the principle that we're going to base today's shader on. And what this allows us to do is keep the details on the rock the same size, no matter how big or small that rock is. And this will allow our artists to scale the rock no matter any size they want to. They can make it huge, they can make it tiny, and the texture details on the rock will stay the same size. Okay, so we've got our texture coordinates here, and now we need to use the texture coordinates to sample our textures. So first, let's sample our diffuse texture here. So I'm going to wire the UVs into the texture sample, but I do want to tile this one 2 times. So I'm just going to add a multiply here, and we're going to multiply these texture coordinates by 2, and then I'll pass that into my UVs. All right, so this is what I'm going to use for my color. And if you'll remember, I put the roughness in the alpha channel here, so I can take the alpha channel and wire that into my roughness. Okay, now let's go ahead and deal with our normal map. If you'll remember, the normal map was not stored as a normal, so we need to unpack it. And the way that we do that is we multiply by 2 and we subtract 1. And this is something that I do in almost every shader video that I make. I take a normal, multiply it by 2, and subtract 1, and then expands the normal vectors from the 0 to 1 range in the texture to the -1 to 1 range that normals actually need to be in. If you set the compression method to normal, it will automatically do this, but because we don't have it set to normal, we have to do this manually ourselves. But this isn't actually costing us anymore because the shader does this anyway. It just doesn't show it to you. So we're not actually adding any additional cost here. We're just doing something that normally the shader does under the hood for you. Now the last thing that we need to do is use a derived normal Z node. And what this does is it figures out the Z component of our normal from the X and the Y. Because we're only storing the X and the Y of the normal and not the Z, remember we put the ambient occlusion in the blue channel here. And so I'm just going to go ahead and wire our blue channel into ambient occlusion. And we've unpacked our X and Y components of our normal and calculated the Z component. And now we can just drag this into our normal socket. So now we have our color, our roughness, our normal, and our ambient occlusion. Okay, so our shader's coming along pretty well, but the last thing that we need to do, we need to do 2 last things actually. We need to use our macro and our micro detail normals. And we need to blend the data that we're storing in these 2 with our base color, roughness, normal, and ambient occlusion. Actually, we're just gonna leave ambient occlusion alone, but we are going to blend the details of our macro detail and our micro detail with our color, roughness, and normal. Before we do that, let's save and just take a look at our progress so far. So here's the shader that we've created so far. You can see it's different from the Unreal version because I've made these rocks a lighter color. If I zoom in, you can see that the texture kind of falls apart because we don't have our micro detail in there yet. And if we scale our object up really big. Oh, no, so this is one thing. If I scale the object up really big, our texture is going to stay the same texel density because we are scaling that texture, the texture coordinates with the scale of the object. So if I scale up the Unreal version of the rock, you can see that the texture detail is staying the same size and it kind of starts to break down. But because on our shader, we're scaling the texture coordinates with the scale of the object, you can see that I still maintain tight texel density, even though my rock is a lot larger. Okay, let's go ahead and add in the micro detail and the macro detail. So here's my macro detail normal, and I want to scale this up, or I want to scale this down actually. So I'm going to take my scaled texture coordinates here, and we're going to multiply them by 0.25. So this texture will be, what that means is this texture will be 4 times as large as our regular, like our regular normal map texture. Okay, to unpack this one, I'm going to add a multiply here. Then I'm going to hold down the 3 key to add a vector 3. And for this vector 3, I'm going to set it to 2, 2, 0. And what this does is it's going to take the RGB value coming out of my detail normal, or my detail macro normal here, and it's going to multiply the red by 2, the green by 2, and the blue by 0. So I'll have a 0 in that third channel. Now I'm going to subtract. And for this subtract, I'm going to do something very similar. I'm going to take a vector 3, and I'm going to subtract 1, 1, and 0. So what I'm doing here is I'm expanding my detail texture just like I did with my regular one. Here I'm multiplying by 2 and subtracting 1. But here I'm doing a little bit differently, and that's because I want my z here to be 0. So I'm multiplying by 0, and then I'm subtracting 0 so that I get good data in my x, my y, but then in my z I'll have 0. And what that allows me to do is to use add to combine my normals, because my z is going to add 0 to it, but my x and my y are going to add good normal data. So normally you have to use something a little bit more complicated and a little bit more expensive when you combine normals. But because I'm using this detail normal and my z component is 0, I can just add these normals together. All right, let's go ahead and wire that into the normal socket, and we'll hit save. And we'll switch back over to our scene. And now what I want to show you is, since we've got these detail normals, if I switch and I go to buffer visualization world normal, now you can see that there's this extra detail in here, and it's going to stay the same size no matter how big I scale this. So if I scale this rock up, you can see that the rock still has some tight normal detail in here, even if this rock gets really, really large. You can see that as I scale it, the UVs are changing size to compensate, and my normal map is maintaining its texel density even though I'm scaling the rock. So the base normal map is scaling up to stay the same size as the rock, but that macro detail texture is staying at the same texel density. So I'm able to scale my rock up pretty big and still get some decent detail in here because I have that macro normal applied. Okay, let's keep going. In our macro normal, in the blue channel, we're storing some roughness data. And then in the alpha channel, we're storing some data that we can use to combine with the color. So let's go ahead and do that. So first of all, I'm going to take my blue channel here, and I'm going to add a 1- node to invert it. And you can see here, that's my roughness data. And so now I can take the roughness data coming out of my base color texture here, and I can just add this roughness data to it, just like that. And then for my color, I can take the color that's coming out of alpha, and I'm going to use a blend overlay node for this. So I'm just going to overlay the data coming out of my macro detail texture on top of my base color here. All right, let's save and take a look at what we've got in our scene now. So here's our normal view, but if I switch to color, you can see that I've got this macro detail texture in here. And if we switch to roughness, you can also see that I'm combining the macro detail roughness with the base roughness. Okay, so that's it for the macro detail, and let's go ahead and add the micro detail in as well. So we're going to do the same thing that we did with the macro detail with our micro detail. So I can just take these same nodes here and copy them, and then we can wire in our micro detail texture here. So I'm going to take my blue channel and wire that into that 1- node there. And then I'll add that to the roughness data that I've already used. And I'm going to take my alpha channel again. I'll just go ahead and copy this blend overlay node here. And I'm going to wire my alpha channel of my micro detail texture into that blend overlay. All right, so you can see that for my color, I'm overlaying the macro detail data here and the micro detail data there. For my roughness, I'm adding my macro and my micro roughness. And then for my normal, we need to do the same thing with the normal. We need to add the micro detail normal in here and connect that up. And we're all done. So now let's switch back and take a look at what we have. If I zoom in, you can see my rock is scaled up here. In fact, let's take a look at the scale. So my rock is scaled up 16.5 times its normal size. For now, let's just set it back to its regular size. And if I zoom in here, so right now we're taking a look at it and it looks like it's really blown out. And this is because I made a mistake. So let's switch back to our shader. The mistake that I made is I didn't use the object scaled UVs for my micro texture. So I need to do that. And I'm just going to go ahead and copy this multiply. We're going to multiply our scaled UVs by 12 for the micro detail. And what that allows us to do is get some really tight close-up detail on this micro texture. So let's save that, switch back to our scene. Yeah, and that's what we were looking for. We can get really close to our rock because that micro detail texture is multiplied by 12, or the UVs for it rather. When we zoom in really close to our rock, we still get this really tight detail. So if we switch over here to the Unreal version of the shader, you can see when we zoom in, the texture just really falls apart and we start seeing blurry looking texels. But on our version of the shader, if we zoom in, you can see that there's this really tight, close detail. Looks really nice, even when the player, gets really close to the rock. And because we have our macro detail texture on there, we can scale this rock up huge. In fact, I'm going to scale it up to 30 times its normal size. And you can see that we still have this really nice high resolution texel density. And we can get right up in really close to the gigantic rock. And we still have nice tight detail. And because the texel density that we have here is matching the texel density of a normal size rock, I can take a normal size rock. I don't know if you can even see this because the two rocks are such different sizes from each other. But I can take a normal size rock and just punch it right into our giant scaled up rock. And the two match each other really well because our UVs are getting scaled to compensate for the giant size of the other rock. And so I can just take these rocks now and scale them whatever size I want, punch them into each other, and get all kinds of cool looking rock formations. And no matter what scale I size them to, they'll always still work with each other and have consistent texel density. Cool, so that's our rock shader. Now let's switch over to Unity and I'll show you how to create the same shader there. All right, so here we are in Unity. And I've taken a rock from the HDRP sample scene and done the same thing to this rock shader as I did in Unreal. So this rock here on the left is the one that ships with the scene by default. You can see if I zoom in here, the detail starts to fall apart if I get too close. But this rock over here on the right is the one that's using my shader. And if we zoom in, you can see there's extra detail here for if we get too close. This detail kind of kicks in and gives us an extra amount of detail. Now, this rock here on the left, if I scale it up, let's say scale it to like 8, for example, now you can see the texel density is really low. And if I zoom out, you can see these normals here when the sunlight is shining on them, you can see the texture resolution is really low right there. However, with the shader that I created, if I scale this rock up 8 times, because I have the macro detail texture in there, it's nice and crunchy. I still have plenty of normal detail for things to look detailed enough. So this rock, I can get really close to it. I can scale it up really large. I can zoom in, and there's plenty of detail close up, at mid-range, and at far away. So let's go ahead and take a look at this shader, and I'll show you how I constructed it. So just like I did in Unreal, I took the base shader, or I took the base textures. So here's the base texture for the rock, and you can see I'm using the alpha channel. I packed the smoothness for this texture into the alpha channel. So this texture is now a color and smoothness texture. I saved it as _CS. And then for the normal map, just like I did in Unreal, this normal map has the ambient occlusion packed into the blue channel of the normal. Okay, so here's my base texture, and I'm taking the X, Y, and Z, or the RGB of the base texture, and this is what's determining the color of the shader, and I'm blending it with the macro detail and the micro detail. So the macro detail data here comes from the alpha channel of my macro detail texture, and the micro detail here comes from the alpha channel of the micro detail texture. So you can see I'm using a blend node that's set to overlay to blend my regular color texture with the macro detail and micro detail alpha channels. For the normal map, again, I'm not storing it as a normal map. So if we take a look at the texture here, you can see that I've got my texture settings set to default instead of normal map. And I've got sRGB turned off. That's really important because this is normal data. It needs to be stored as linear, not sRGB. And then you can see I set my compression to high quality. And in Unity, when you do that, it sets the compression type to BC7, which is what I want. Okay, so for this normal texture, I'm using the normal unpack, which does the same thing as the ×2 - 1 that I was doing in Unity. And then I'm doing the normal reconstruct Z, which takes the X and the Y of the normal and calculates what the Z component should be. Then you can see I've got a vector 2 coming in here, and I've got a vector 3 going out, which means it's completed the normal. So there's my base normal. I have to use this unpack and then this normal reconstruct because I'm not saving the texture as type normal map. Normally, this stuff happens under the hood. It's still happening, but it's happening under the hood. But when I don't store it as a normal map, I have to add these nodes to do that myself. And the reason that I do that is because I wanted to store the ambient occlusion in the blue channel here. And you can see I've got that blue channel wired directly into the ambient occlusion input port of the master stack. Oh, I probably should have talked about this first, but I've got my UV coordinates here and they're multiplied by the scale of my object. So just like I did in Unreal, I'm scaling my UV coordinates by the scale of my object, which allows the UV coordinates to stay the same even when the object is scaling larger or smaller. That's the way we maintain our texel density. And then I take those scaled UVs, and for the macro detail texture, I'm multiplying them by 0.25. But for the micro detail texture, I'm multiplying them by 12. So we scale those UVs really small for that detail texture. And then for the macro detail, we actually scale them down a little bit. All right, so here is our micro detail texture. I'm taking just the X, Y, and Z, multiplying by 2 and subtracting 1. And just like in Unreal, I'm doing this little trick here where I'm multiplying by 2, 2, and 0 so that my third component is 0. And then I'm subtracting 1, 1, and 0 so that I've got my normal data in the X and the Y, and then in the Z, I have a value of 0. And what that enables me to do is to take this normal data and just add it directly with my normal here. So here you can see my base normal map, and then I'm adding in the macro detail and the micro detail here. Okay, so and these two textures are handled pretty much exactly the same way, except for this one, the UVs are multiplied by 12, And this one, the UVs are multiplied by 0.25. So the macro is larger and then the micro is teeny. So for each of these, I'm adding their results to the normal. I'm overlaying their results with the base color, and then I'm multiplying their results with the smoothness. So here's my smoothness in the alpha channel of my base texture, and I'm multiplying that with the blue channel of my macro detail and multiplying that with the blue channel of my micro detail. All right, and then the end result, I get a rock that looks like this with nice tight detail close up, and I'm able to scale this rock to any size and it'll still have nice tight detail close up and far away, no matter what scale I scale it to. Now, of course, you know, I could scale it to 500 and then the texel density would fall apart at that point, but this gives you a really big range to play with, scaling the rock down and up. And you can still blend rocks of different scales with each other. So it's a nice production-ready rock. So last week we created a snow shader, and so what we're going to do in next week's video is I'm going to take that snow shader and combine it with this rock shader to create a shader that applies some nice snow on the top where you can control how much snow is applied. So be sure to tune in next week for that one, and I hope you enjoyed today's video, and I hope you have a great week. We'll see you in the next one.